Hello to my talk about profiling PHP, and I would like to start with a couple of questions to know the audience better. Who uses PHP? Okay, cool. Everybody in this room, I guess. If not, maybe you should leave. No, just kidding. Who has already made the switch to PHP 7 in production? Okay, a lot. It's nice. Maybe some early adopters of 7.1. It's get tagged today, so one person. Cool. PHP unit. Who's PHP unit? Okay, almost the same guys. It looks like either you are testing your code or you feel ashamed of not doing it, right? And the same should be true for profiling, which is, I think, not the case yet. So why I'm doing this talk is also to place it in the that we have this assumption also with profiling. So it's true also for profiling. Two last questions. Who use Xdebug? A lot of hands. Cool. And the last one, Blackfyre. Okay, that's good because it's not a lot of hands, and I want to share with you mainly this tool and also others. So thanks for participation again. Now a few words about me. I'm Sebastian. I work at Showroom. It's the leading European marketplace for independent fashion designers and brands. We have our headquarters in Poland, in Warsaw, but we have an office in Berlin too, so maybe when you are from Berlin you might have heard about us, but we're just getting started in Germany, so maybe not yet. Did you know that 40% of users abandon a website that takes more than 3 seconds to load? And this is a conclusion done by, from a research done by Akamai, the provider which basically gets, I think, half of the internet traffic through his servers. And what it basically means that your website has to be faster than that. You might have also heard about Google's case study where 500 millisecond delay caused 20% traffic decrease, or for example, Amazon, where 100 millisecond delay caused 1% drop in revenue. So, what is profiling? MathWorks says profiling is a way to measure where a program spends time. And put simply, by Fabian, profiling is about gathering data. So, how can we do that? Microtime, for instance. So let's start with the built-in tools. So Microtime. When you want to profile, measure something with Microtime, you have to, like Microtime returns the current timestamp with microseconds, that's the name, Microtime. So you enter the script, you pass the current variable, the current timestamp to a variable, for example, start in this case, do something in your code, and that's your business logic you want to measure, and then do the check again. And then you have two variables you can subtract, and you have the timing. So basically, that's it. Another way of doing, I think, the same thing would be using the request time float. It's a server variable. This way, you don't have to pass the starting time variable throughout the application, and timing also includes loading the script itself, because it's like one level above. What you should do with the data, you should write it to disk, or you can write it to Redis, or anywhere else, which lets you analyze this data, and hopefully it's in real time, so you know how your application is behaving. If you go with log files, so you basically writing the timing to files, and you are using Nginx. Already, you could measure upstream response time directly by setting up a custom log format and referencing to it, just like on this example. You can, of course, put the standard variables in there, but they wouldn't fit on my slides, so you have to just add upstream response time, and it gives you the backend time the PHP process took to get a response. So let's look at another built-in function, which is MemoryUsage, which returns the amount of memory in bytes that's currently being allocated to your PHP script. And the usage looks roughly the same as with Microtime. you measure the time before your business logic, sorry, not the time, the memory usage, then do your stuff, and then call the function again, and again you have the subtraction, and you know how much increase in memory was involved in this process. That's it, because it's not like an advanced function. So what are the advantages and disadvantages of those two functions? So it's a plus that they are included in PHP, so you don't have to do anything to get them. And I think it's quite easy to understand, so I don't think anybody has a problem with understanding the usage of those functions. On the other hand, they provide only raw numbers and lack context, so you don't really know what to do with those numbers. And moreover, and that's an important issue, they require code change. So if you want to measure something, you have to write it down in your code, and in every place you want to measure. So it's not really like, it's a no-go for readability of your code, and thus for production usage. So let's have a look at another tool. It's Xdebug. I've seen a lot of hands up, so I bet those of you who use Xdebug use it simply as a debugger, and I guess it's also the reason why it's called Xdebug in the first place, and why it's such a great tool. But Xdebug comes also with a built-in profiler, which outputs profiling information in the form of a cache-grind file. So all you need to do is a simple config change, and of course the extension itself. And once set up, you can trigger profiles, for example, appending the Xdebug profile query parameter. So the profile gets written to disk. There's, of course, CLI script support. So you have to trigger it another way, or you can just enable it for all the requests, which is not recommended because your disk will get filled very quickly. So the outcome is a cache-grind file, as I already said. And it's profiling data written to disk. It's like in the config you have to point to your directory where the data comes in. And this allows you to use, for example, kcachegrind. It's a Linux tool to analyze it. Or you can use a web-based tool called repgrind. So what you get is a tree of functions, function calls and their counters, which you can explore. So you can also sort them. You see the total timing, for example, 342 milliseconds, which function has a counter beyond 10, and so on. So you get an overview of, first of all, what is called in a single request, but also what's the most expensive function in terms of call count, but also in terms of timing. So what are the pros and cons of Xdebug profiler? First of all, you don't have to change your code, because the profile is generated on the entire script you're running, and it's done by the extension, so no zero code change. Second, the output is a cache-grind compatible file, which gives you the freedom of choosing your favorite tool to analyze it, and I've just shown you two of them, but there are more of them out there. You can write your own. The drawbacks, you need an extension, so comparing it to the previous built-in functions, it's maybe not such an issue, but then the extension itself has a huge impact on performance. So roughly saying it's like 50% slower or 100, it depends on the code and how many files you have, but it always, you see the difference. So regardless, and it's regardless if you are profiling or not, because Xdebug itself has an overhead. So this makes it unsuitable for production, so you only can profile your development environment. So let's have a look at even another tool. So it's an even better tool, so I try to go from the least fun to the best. So it's called XHProf, and it's a tool originally developed by Facebook, and it was open sourced in March 2009. And with the extension pre-installed, you have to manually the profiling and write the gathered data to somewhere on your own, because it doesn't provide it out of the box. So worth pointing out is the fact that this tool can be used in production because it has no overhead once it's unavailable. So the extension is present, but you don't profile, so you don't call xhprof enable. And the recommended way of profiling in production is to run it on a fraction of your traffic. So you have like a random function and say, okay, every let's say thousands requests should go through this profile. And if you are using Symfony, most probably you are, there are bundles available for this. So you get the persistence support, writing to a database. I think that's the default one with this bundle. And also this triggering rules, how many requests should be profiled like this. Similar to Xdebug, you get various graphical user interfaces to explore the data. And this one is among the simplest and ships with the source code. So that's why I'm showing it. But there's also like a tool called XHGUI or something, which looks a little bit nicer. But yeah, the data is the same. So it's just a way of showing it in a different way. And you get a little bit more data. So we have, of course, the function calls. Then you have the timing, which is divided into inclusive and exclusive. I will explain it in a minute. And also CPU and the percentages, and you can click in these functions and go deeper and deeper. Like the main function is, of course, nothing. It is 100% wall time because it's like entering the program. But then you have to figure out which function is it's like responsible for performance bottlenecks, if you have any. So why I'm saying it's a better tool? First of all, because it's the first tool suitable for production usage. And I think that's the most important environment where we want to profile. And I have been using it on a probably biggest Symfony-powered project in Poland, and with great success. It was some time ago, but we had these fraction of the requests profiled, and we could have seen if it's getting better or worse over time, and which sections of the website were getting having a performance bottleneck. So the cons is, unfortunately, the project is no longer maintained by Facebook, so they've like switched the stack a bit, and it lacks support for PHP 7. And as you are, a lot of you are using already PHP 7, it's, I think, again, a no-go. Which brings us to Blackfyre. So Blackfyre actually started as a fork of xhprof. So it's made by Essential Labs. You might have figured out already, because we have a stand there. By now it was completely rewritten, but it started as a fork of xhprof. It has support for all latest PHP versions, including 7.1, so you can use it basically on all versions. And worth pointing out, I think I can make it even bigger, it is a hosted solution. So the concept looks like this. You have a probe here in the middle, which is the PXP extension, talking to an agent, which you have right here. And the agent is also part of your infrastructure, the two components. The agent, on the other hand, is talking to the hosted service provided by Blackfyre, which we have here. And to trigger a profile, you can use the optional, because it's optional, browser extension called the companion on this graph, so on the left side. But there are also other ways to run a profile, and I will show them in a minute. Let's start with two definitions I've mentioned earlier. First, wall time. So wall time is the time spent on CPU plus I/O. And I/O is, in turn, is network plus disk. So basically, wall time is CPU plus network plus disk. And also in this profiling data, you will see we have this like separated here, so you can focus on each of them. Second definition, inclusive versus exclusive time. It was also on these output from xhprof. Inclusive time on the left side is the time spent on the function call and all the functions that it is calling itself, so like foo and bar inclusively. Exclusive time is just like kind of the opposite, so it's just calling the foo function without any sub-function calls. So inclusive time is always higher than exclusive. And Blackfyre is an all-in-one solution. You can and should use it in development, staging, and production. So in all stages. In development, it gives you like the ability to debug your code and improve performance, like you're doing a change and then see if it's getting better or worse. In staging, it lets you test and validate your progress when you are shipping the code, and hopefully this is a production-like environment, so you can have different results, but then they're more production, closer to production. And on production, you can like monitor your application and identify real issues with real data, which you don't have in the other environments. You don't have the traffic and so on. So actually, one of the first things I've done after switching companies was installing Blackfyre on the production server, because I didn't know anything about the source code of the account. I know by now, but when I switched, I didn't. So I've enabled it on production, and it turned out we had Xdebug enabled on production. Okay, you can say I might have figured it out just looking at the config, but it's just like when I know what could be wrong, I can check it, but if I don't know what's wrong, I can just install Blackfyre and see if everything is performing quite fine. So that made us like roughly 50% performance improvement, because we just switched off Xdebug, and later also could have find other bottlenecks, but this one was obvious, and yeah, easy win, like 50 minutes win. It's 50 minutes of time and a big win. The user interface, in my opinion, of course, it's a big step forward comparing to what we've seen before. So what is available for Xdebug or XHProf. So what you get, I will show it on real data also, but what you get is a toolbar at the top with a summary of the most important metrics, and this toolbar is also placed on your website when you are profiling. So it's just like appended on the top, like the debug toolbar from Symfony at the bottom. And it shows like wall time, I/O time, CPU time, and memory usage. That's there are more metrics, but these are the basic ones, and because it depends which plan you take also. On the left side, you get a list of function calls, and it's basically the same as with the graphs I've showed you before with Xdebug and XHProf. So you get function calls. You can sort by exclusive and exclusive time. By default, it's sorted by exclusive time, because it's like that's the function call you should be looking at in the first place. But maybe you're searching for something different. And then you have also a search bar, so you can filter these functions and so on. On the right side, you have a draggable call graph, which you can zoom in and zoom out and like click also on them, and then we have this popped up on the left side, but I will show this in a minute. Within the call graph is a so-called hot path. So it's shown with the colored borders, which shows you the right, the path you should, the performance bottleneck to be, yeah. So this is the candidate for the bottleneck, because it's the function call tree which takes the most of the time, and moreover, the most intensive node, like a single function call, is also highlighted with a solid background. You can see on this slide. So a demo, first with a Chrome companion. I will start the Chrome extension, and it is installed. It's like an icon in the right upper corner. And the application here is like a sample application. This should be your application, but to tell you what it's about, I have picked a basic tool, which is also like picked in the examples by Blackfyre, so I don't want to use my own. So it's a tool called GitList, and it's like basically a Git repository viewer written in PHP. And it has performance bottlenecks, or it had at least. So with the probe, the agent, and the companion installed, I just fire up a profile within the browser. Okay. And I just click profile. I got this toolbar on the website, but then I can go into the details, and I see it took 32 milliseconds to load. It's the wall time. And the most expensive function is writable, which took less than 3 milliseconds. So it depends on your code if this is a good timing or bad timing. I will talk about this in a minute. But for me, I think it's quite good. So let's try by like random other side. Let's try another side. So I will just click on another page, which is doing a listing, and profile again. And as you see, the progress bar is getting a bit slower, and 253 milliseconds. So like a huge difference. If we can take this 32 milliseconds as a base, it's like it has some bottlenecks. And if we see the function that took the most time, we can also see which function call it, and it's a good version function. It is our code because the first function was a native PHP function, so we can't do anything about the function itself, but not calling it, yeah, because we can't improve the timing. What we can do is not call it so often, and that's what we're gonna try. So the source code for the get version function looks like this. And what is the function really doing? It makes an expensive system call, like calling the system where the PHP application is hosted, and gets the Git version available on the server. And it does it 10 times, as you've seen on the profile. So how often do you think your Git version on the server will change during one request? Never, right? Okay, so we can try to a simple solution and cache the results of the lifetime of the request. Just make an assumption, and that is our business logic, that it won't change in a single request. It wouldn't change in a couple of requests also, but then it makes our caching a bit more complex. So to keep it simple, we can just add a static variable and then set it on the first entrance in the function, and later serve it from the cache. So let's profile the page again with the fix applied, of course, and compare results. As you can see, I've made a reference already of the previous profile. So when I'm hitting profile right now, I'm right away comparing these two. But you can do this also later, so it's not like it's just a shortcut. And what we see is 7% decrease in wall time. But to be honest, it's not like you should always look at the wall time, only at the wall time, because it's just like it's the consequence of a bottleneck and not like the reason itself. And it may vary between requests. So it's not like a good indicator if it's getting good or bad. So what we did, we wanted to cut the calls to the get version function to just one call to the system. So we have to make sure this is what's happening after the improvement. What we can see, we had gained wall time from about 40 milliseconds on this improvement. But as I said, it's not clickable because it's recorded. But it's even more important to check if the stream function wasn't called so often, to make sure our improvement is working. And on the graph, we see it, of course, in blue. And that's a good sign. If we see any red, it could have been that we fixed one place, but like made mess in another. So it's also worth paying attention to it. So another way of doing a profile. So if you don't use Chrome, for example, because you don't want to, or you just feel like home in the terminal, you can. So feel free to use curl. Just type Blackfyre at the beginning and a typical curl command. But I guess it's almost the same data we've seen in the toolbar, plus a link you can follow. So there's some red, some recommendations, but it took 40 milliseconds it was the homepage. The previous one took 32. You see there are some differences, but it's not like twice. You can also see there's a counter up there, because by default all profiles are taken 10 times to make average, so like to gather the data of 2 separate profiles and merge them into one to get better results, to not have so many differences if you run another profile against it. So then you can just follow the link and you get to the same page as previous. But with curl, you can also do a lot more. You can do everything you can do with curl. So let's say you want to profile a request exactly as it is in the browser. For example, you have some headers, some cookies, you are logged in, or it's an API or something. Again, with Chrome, but other browsers have it too, you can put the DevTools up, and then you can just copy exactly the same request as curl to your clipboard, and then paste it in the terminal. So you have this copy as curl, but I think it's the same in Safari and Firefox, as far as I remember. And then again, Blackfyre, and then the whole command. Okay, so this is just an example. As you can imagine, you can do post requests, put requests, head requests, anything you want to do. You can put a body in it, or just replay some stuff. You can, if the post action is like you can't repeat it, it's like you can only a one-time call, for example, send an email or something. You have to limit the samples, so you can say minus samples 1 to make sure it's just one sample. And then with curl, the sky's the limit, so you can use all of curl functionalities. But what about CLI? So if you are running some workers and you want to profile them, you can imagine there is a way of doing this. So from I will do a sample script. I will write it like demo PHP, and it's just a script that sleeps for 3 seconds. So not complicated business logic. And then I can profile it. I can imagine you know the result. Then I do just Blackfyre run and anything that is PHP. It could be Blackfyre run Composer, for example, and then I can see how much does Composer take for the listing. So no surprise here. We have 3 seconds. With the end, but roughly 3 seconds. And following the link, we can go on the website and see indeed the sleep function took 3 seconds, no surprise here. And it's nothing more. So there's something, if it's our application, we have to improve. Okay, you mean the timing on I/O? Yeah, because you have to parse the script itself. It's a CLI application, so you don't have opcache. Yeah, but sleeps is, I think it's it's coded like you have to wait on I/O. So it's like the code beyond the sleep function itself. It's waiting on the system side, not like CPU. It's not like you could make a sleep function with during a while loop. It's hard to calculate how long it take, but a while loop with say 1 million iterations, it would take some time, and this would be CPU, but it doesn't make sense to to kill the CPU, so sleep does it another way, as we can see. So I don't know, I'm not 100% sure, but I think that's the reason. Okay, so if you have finally figured out how to measure things with either Blackfyre companion, the Blackfyre curl command or the run command, so you know how to measure these things, and you agree on what is good or bad. So you have to know which timing is good or bad in your case, specific case. There's no magic number. You can use assertions to make sure your best your standards are met. So assertions are placed in a YAML file within your repository. So you place the Blackfyre YAML file and then put the assertion in there. And let's take some real-life examples from my company. So our e-commerce front store, so it's a front page where you can buy items, is an API-based application. So, which means it shouldn't talk to a database. It's just calling the API. So we've put an assertion in place which is labeled "application should never hit the DB," and it is covering all URLs. Notice the regular expression with this /.** in place of path, so it covers all URLs. And the assertion itself states that the SQL queries count should be equal to 0. That's a built-in metric in Blackfyre, and it covers all databases, all SQL databases, so it could be Postgres or MySQL. But then, if you want to make sure it's a specific database, you also can add the specific metric. Using an API means that we cache a lot. So we've put another assertion in place just for our homepage, which says homepage should never call the API, which ensures that cache is always warmed up. The metric is simply that no HTTP requests are made within the script, responsible for rendering the homepage. And as again, we know our application, so we know the only HTTP request we are making is to our own API. So we want to make sure on the homepage there is 0 requests to an API. One more, pages should be fast enough. And I think that's the whole point of profiling and optimization efforts. So it again applies to all URLs and checks if wall time is below 100 milliseconds. The number may of course differ in your case, but it again makes, I've said previously, don't make assumptions on wall time, but then this is the upper limit. So it's basically on the whole website, so it's hard to distinguish between all the parts. So it's a global metric, and then on specific web pages or parts of the website, we can have more granulated metrics when we have other assertions there. So these are 3 of our assertions, and they are present on almost all the websites, all the sub pages, to be more specific. And these assertions are then checked every time you profile. You make a profile, and they're listed right on the left side, so they're fired up. The regular expression for the URL is, of course, parsed, so this is the homepage. If it weren't, the second metric assertion wouldn't be there. So it's first checks if the assertion should be run, and then checks the metric itself. So we see everything is green, so we have no DB calls, we have no API calls, and the wall time is below 100 milliseconds. So it's cool. Oh, I have bigger here. Okay. So builds. Another cool feature of Blackfyre. I won't cover all of them, and I think there might become also new ones during this conference. I don't know. Builds are a cool tool that lets you trigger profiles automatically, and you just specify the URLs you want to check. So for example, the home page, we have a tag page where we have all products, a brands section where we've listed all the brands, a specific brand and a specific product. So to make the most critical pages tested. And it's a simple profile where you're not logged in, because it's just like if you've done it with curl. And they get called every hour, and we get like a report of it and see, yeah, if the assertions were good. And if something went wrong, we get immediately notified. So it's just like with your test suite. So if something breaks, you get notified. And these are basically traditional profiles, so you can get into detail in every one of them. So just click and see if something is going wrong, so what went wrong, especially after a release. Yeah, so that's our metrics. And there's also a Blackfyre PHP SDK. If you have a special use case, you can always use the SDK if the default functionality of Blackfyre doesn't cover your needs. So you have more control. The typical use case of using an SDK, what I can imagine, is profiling long-running scripts. So if you have a worker which is just pulling data from, let's say, a RabbitMQ, you can't just profile the whole process because it never ends, or ends once, I don't know, a day or a week when it gets killed. But then you can just use the SDK and do so with require by composer. You can pull it in, so you have autocomplete, and then call the new Blackfyre client, create probe and end probe. So you can do this on a fraction of your loops, or a one loop, or a single loop, and so on. So you have more control to like profile your code. And Blackfyre comes also with PHP unit integration. I've seen a lot of hands before, so it might be interesting, because it's very hard to make assertions on metrics to whom you have no access in a traditional integration test without mocking everything out. So this is especially true for legacy applications. So if you have an application and you don't have tests yet and you want to cover them, this might be a good approach. So you can make like an integration test or functional test, call a real controller, and without replacing everything with mocks, which might be impossible during the current state of the code, you can still, with the extension, test some metrics on SQL counts or rendering templates and so on. So I think it's awesome for legacy applications to cover them. And we don't have a lot of time because I want to share a use case, so I get just quick through it. It's online, so you can read it on your own. The title is "Increasing Goldline's Email Throughput by 110% with Blackfyre," and basically it was we had an issue with sending emails. We have been sending 6 to 7 million emails a month, and sometimes we have spikes during an announcement to our 2 million users database. So we have to like push 2 million emails immediately. And our system was built on a database. So every email that was like generated was put into the database. It was already a rough email, so it was plain HTML and the text that would be sent out. But we used the database because we wanted to make sure we have priorities. So, for example, when we generate an announcement to the user base, they would get into the database, but the sending would take some time. We used Amazon to send them out. So when somebody, for example, clicked "Remind my password" or "Reset," he or she would have to wait for the emails to go out, and that's why we used the database to just give them priorities. And by then we thought it's the only that's a good solution to work with. But we have, of course, we had some performance issues with this. We wanted to push more emails out, but we couldn't. So that was also the time where I fell in love with Redis. So I thought, okay, the database might be the biggest issue because we are sending emails. The database is not a query. Everyone is telling you that, but we still were using it. So I just said, okay, I drop my current project, I will rewrite it, and I rewrite it to Redis. And then we thought a minute longer about this solution and say, okay, let's make sure it's a database issue. So what we've done, we have profiled it, of course, and it was a process which took 5 minutes. It's always 5 minutes, and we just wanted to optimize how many emails can we put out in this 5-minute time window. And it turned out that database was about a second of this 5 minutes. The read and write to the database was just 1 second. So all of the CPU and I/O, it was I/O bounded with getting through SMTP to Amazon, because SMTP is very chatty. You have to do a couple of calls via internet, and we have just made the switch to use an API call, and then increased our performance by over 100%, and that was the solution. So don't make assumptions, you know, that it feels bad that you use a database, because that wasn't an issue. You can read more on this website. I also recommend the Blackfyre 24 days blog post. It's like in the documentation right now. You can also try to get a hard copy at the desk by Blackfyre. I hope they have some more, because it's also using the same example with git list, and there's even more. So I'm not able to cover it all. So a lot about Blackfyre, and we are running out of time. So I wanted to briefly mention 2 other solutions to give you like a complete overview what's available on the market. So one of them is New Relic, and New Relic is a hosted solution. Comes with a lot of metrics and is meant to be used in production. With the PHP extension, which you don't have to have, but it's worth installing. You get even better insights into your PHP application performance, like time spent, especially in PHP, in Redis, or anything else you are using, database calls, transactions, and so on. But as I said, I won't go into the details because this could be a talk on its own. And last but not least, Tideways. Tideways is a tool built exclusively for PHP, and thus has a deep integration with all the libraries and frameworks, including Symfony, of course. And is collecting low overhead traces of your application's behavior, so you get notified immediately when there's an emergency, and is also meant to use in production and on Linux machines. And it's also a great tool, and you can use all the tools at the same time. It's not like all of them have unique features. So we are out of time, but maybe there are some questions.
Is there any memory usage profiling in Blackfyre?
Yeah.
At the function call?
Yeah, you get, it's always divided into CPU, I/O, and memory, and also network, if you want, and then you have the SQL queries and so on. But and then each function call, for example, the stream get response or something, or is writable function, any function call has its own timing, CPU usage, I/O usage, memory usage, and so on. So you also see, you can sort not only in the timing, by timing, but also by memory usage if it's the biggest issue you have. Yeah.
Did they actually manage to get the under 100 millisecond test for all the websites?
Yeah, it is passing. Every page is below 100 milliseconds. Yeah.
Thank you for the talk. In most cases, the front end is just a client that calls API, and we are interested in the performance of the API backend project. Is it possible to trigger the performance from the front end?
Okay, so you're talking more about an Angular app, which is calling an API directly. Yeah, but it's the PHP application itself.
Yeah, it's PHP, but it just calls an API to
Yeah.
another application.
Yeah.
Is it possible to trigger the performance profiling from this front-end application?
Yeah, you can. So the profiling works like this: that you get when you run the profile or you run Blackfyre, it's like adding a special header that knows, and it's signed, so it's secure. You can only use it. So it knows it has to run the profile, and what you can do is just pass the header. As we're out of time. So thank you. My slides are already online on SpeakerDeck, and that's my Twitter so you can follow me if you have any questions. I will be around today and tomorrow, so feel free to. Thanks.